Okay. All right. Okay, so Ginny's Bakery makes two types of birthday cakes, yellow cake, which sells for $25, strawberry cake, which sells for $35. Both cakes are the same size, but decorating and assembly time required for the yellow cake is 2 hours, while the time is 3 hours for the strawberry cake. There are 450 hours of labor available for the production. Right? How many of each type of cake should be made to maximize revenue? Right? This is what they look like. A ton of information. And from that information, somehow we are supposed to create our system of inequalities and an objective function. And I'm going to talk, there's 3 steps, right? Step number 1, you have to read the problem and figure out what you're trying to maximize or minimize. And hopefully that is the easiest thing to find. So you go through, you scan the problem. And then it's usually at the end. Sometimes the problems are tricky and they stick it at the beginning. But if we look at this, my eyes focus on this and it says, how many of each type of cake should be made to, I see this word, maximize revenue. And when I see maximize or minimize or whatever, that's where my eye focuses. And so when I see maximize revenue, I've now identified what I'm trying to optimize, what I'm trying to either maximize or minimize. And that is going to give, we're going to create our objective function. And so here's how it works. It says revenue. So if it says revenue, all right, I'm going to say R. And my job is I need an equation for R. I need something that tells, I've got to somehow read this massive paragraph. And from this massive paragraph, I have got to figure out what's going to give me, what's going to be something that deals with revenue. All right, so I'm going to open the floor. If you read this whole thing, there's tons of numbers. Is there any number here that talks about money? Because we're talking about revenue. Is it easy to identify any number up here that talks about money? Throw out a number.
35.
Perfect. It says $35, right? Right? Everybody, is that easy to find? Right? As long as we know we're looking for money, right? This says revenue, right? Revenue's money. So I don't have to look for all the numbers. I'm just looking for money, right? I see $35. I see the $25. Now, so if I needed an equation, if I needed to put something over here that's going to generate revenue, any brave soul want to tell me what I can write here? Use X and Y, by the way. This is crucial. If you can do this, the rest of this problem is going to be easy.
35x plus 25y.
Perfect, right? Right? And you go look at it. It's like, how am I doing revenue? Well, these sell for $25 each, so I forgot it. I'm going to do in the order. I think you said 35x and 25y. Yeah, I'll do what you said. So 35x plus 25y. Okay? Because it talked about revenue, right? Since it talked about revenue, I'm talking about money. The only numbers dealing with money are 25 and 35. And now, so if you can do this, I'm going to say you're 70% of the way there. You're most of the way there. You've done the hard part, right? So just recap what we did. What are we trying to optimize? They said revenue, okay? Fine, I can find that. We're looking for max or a minimum. I can say, maximize revenue. I write R. Then I say, okay, revenue. What's revenue? That's money. Okay, so what do we have up here that deals with money? Okay, there's a 25 and there's a 35, and I'm going to stick X's and Y's. Now, this part, it seems silly, but it's actually really important. You have to tell me what X and Y represent. So based on this, what do X and Y represent? Like, what does X represent?
How much?
No, that's what it says, right? So here's a key. All right, here's this sort of clue. X and Y are always going to represent a number of something. It's going to represent the number of whatever. So I'll go ahead and get you started. So X is going to represent the number of something, and y is going to represent the number of something. So what does x represent?
The number of strawberry cakes.
Perfect. Number of strawberry cakes. Okay, sorry, handwriting's awful and this gets recorded and everything. So if we know that x represents the number of strawberry cakes, then this is number of yellow cakes, right? We're 80% done. This is the hard part, all right? And I kind of want you to think this isn't that bad. And the reason I want you to think this isn't that bad is I'm telling you the order in which you need to think about things. Because if you try to think about them any other order, this gets absolutely miserable. So just, again, I'm repeating. What do we do first, right? You have to identify what you're trying to optimize. They usually tell you by either maximize or minimize. You write, it says revenue, so you write R, and then you think, okay, I got to come up with revenue. After you come up with your equation, then you want to come up with what do X and Y represent, right? Now, we need to come up with some inequalities. So how do we do that? We read our big paragraph again, and we look for restrictions. We want to look for, what are my limitations? Like there's always some sort of constraints. So when I go through, okay, if I read this whole thing, what are some restraints? Like, what are my limits of the factory?
The 450 hours of labor.
Yeah. No, key words for that. They talk about, they see the word available, right? Other words are, they'll say you have at most this much space or at most this much time. But your key word, or you only have this much available. So when I look at this, I've got other numbers, but that's not restrictions. That just sort of tells me how much time it takes me to do something or how much money it costs to do something. So if I've got this, if there are 450 hours of labor, then that's like a maximum. I can't use any more. That's it. That's the most I can use. And now what I need to do with that 450 sort of combined labor, I need to talk about how much time I spend for strawberry cakes, because this is time. I need to talk about how much time I spend for strawberry cakes and how much time I spend for yellow cakes. And I'm going to add them together. And it tells there's 3 hours for the strawberry cake. Since X is strawberry, I'm going to have 3X. It says there's 2 hours for the yellow cake. So that's plus 2 hours. Right? And so this is the hours for strawberry cake. This is the total hours for yellow cake. So when I add those together, they have to be less than 450. Well, now we have to put our stupid restrictions, right? Our stupid restrictions are, you're not making negative cakes. So I'm going to put X is greater than or equal to 0 and Y is greater than or equal to 0. Have I used all my numbers? I think I have. So I've used all my numbers. These are my constraints. And that is my objective function. And how we would finish this problem, and I'm not finishing the problem today, is I would graph these. That would give me a feasible region. I'd get my coordinates, and then I'd plug my coordinates into this and figure out which one gives me the max and which one gives me the min. Right? So this is an easier problem. We will have some, actually very shortly, we will have some where your number of constraints gets a lot more than this, so it makes a little more complicated feasible region. All right, so just recap. What did we do first? And what we did first? The first thing we did is we identified what we're trying to optimize. The second thing we did was write that equation. When we write that equation, that's going to help me figure out what X and Y equal. and X and Y are always going to represent the number of certain things. So the number, in this case, strawberry cakes, and the number of yellow cakes. After we identify what our X and Y are, then we reread the problem and we look for some restrictions, like how much space we have, how much time we have, how much money we have. And we use those restrictions to create our constraints. We get a system of inequalities, and tonight I'm going to make you graph and finish all this. So now let's look at our next problem. All right. Scroll up to the top. Oh, can't scroll up to the top. All right. Says a brochure costs 8 cents to print, and each flyer costs 4 cents to print. A brochure requires 3 pages, and a flyer requires 2 pages. The manager does not want to use more than 600 pages. She needs at least 50 brochures and 150 flyers. How many of each should she print to minimize the cost? All right. So it looks a little shorter, but they've actually given more information in this particular problem. So we go through. What are you trying to optimize? Do we see the word maximize or minimize? So somebody cut your mic off and tell me, what are we trying to optimize? Someone cut their mic off. Come on, tell me.
Minimize?
Well, no, what are we trying? No, what is it? What are we trying to minimize?
The cost?
The cost, right? Minimize the cost, right? We look for the word maximize or minimize, but when we write our equation, it's got to be something, right? I'm minimizing cost. So now I'm going to minimize cost. So I'm going to write down C equals, that's cost, right? So if I want to minimize cost, that has to do with money. Is there anything in this problem that talks about money?
Yes.
Okay. What?
The 8 cents and the 4 cents to print.
Okay. So it's 8 cents to print what? Okay. So there's our cost. So what goes here? This is the part you got to think about. What's going to go here? You're going to use X and Y.
0.08x plus 0.04y.
Perfect. So 0.0x plus 0.04y. All right. All right. So we've got it. This is our objective function. This is what our goal is. All right. So now I've got my objective function. Now I need to know what X and Y equal. And I'll go ahead and tell you X represents the number of something and Y represents the number of something. So what's X going to represent? Number of what?
Brochure.
Perfect, brochures. And then this is going to represent the number of flyers. Okay. Now we go through the rest of the problem and we look for restrictions. Okay. Do we have any restrictions? Like the maximum I can use?
They don't want to use more than 600 pages.
I can't use more than 600 pages, right? That's a restriction, right? So I'm going to go over here, and since I can't use more than 600 pages, I'm going to put 600. And since I can't use more than that, I'm going to put, 600 is bigger than whatever I put over here, right? And since this is talking about pages, right, I'm going to call this my page inequality, meaning everything has to do with pages. There's a 600 pages here, but I need to know, well, I've got to talk about my brochures and flyers. Since I've got to talk about my brochures and flyers, then I need to know, like how many pages, total pages I'm devoting to brochures and how many total pages I'm devoting to flyers. And one little shortcut you can do is, since we're making both brochures and flyers, I'll go ahead and put an X and I'll put a Y, because for my brochures and flyers. And I just have to figure out what numbers go in front of those. So, reading the problem, do we know what numbers go in front of the X and the Y?
How many pages are in a brochure and how many pages are in a flyer?
Okay, so what goes in front of the X?
50.
Well, pages.
3.
3. Everybody see it says brochure requires 3 pages? Because remember, this is our page inequality. Everything on this line has to do with pages. So then that makes this a 2. All right? We've got 1 inequality. Yay. Let's talk about what this means. She needs at least 50 brochures. Well, if she needs at least 50 brochures, that's talking about X, isn't it? Because X is the number of brochures. So since that's talking about X, then I know at least 50, that means X has got to be greater than or equal to 50. That's what that looks like. And we need at least 150 flyers. And since flyers are Y, I get to say that Y is greater than or equal to 150. Technically, there's I call the stupid restrictions. We don't really need them because it's X and Y are both greater than 0. Well, I've already got a restriction that X is greater than 150, greater than 50, and Y is greater than 150. So there's our system. Those are our constraints. Here's our objective function. And how you would do this particular problem is you graph this system, find your shaded region, and your feasible region here is literally just a triangle. Then you get your coordinates and you plug them in. All right? Let's try one more. And this is actually off the other one, because I think this is about as far as I'm going to get today. And this is an example of a harder problem. Whoops. Probably help if you could see it. Okay. And I should have deleted this. I got this from somebody else. And they're kind of the same. But all right. So this problem. Oh, and the bell's about to ring. So here's what I want for homework. The 2 problems we just did, right, where I set up the constraints and the objective function, what I want you to do for homework, and you already have the answer, right, because you can kind of see it in there. What I want you to do, because I did these in a little out of order, I will put another page for your homework 5. I want to see where you draw the picture, like where you find the feasible region, find the coordinates, and plug it into the objective function. So that's literally 2 questions that we've done most of the work for. I just want a picture. But I've got 4 minutes and I don't want to waste it, so I want to talk about this. All right. So a manufacturer wants to maximize the profit for 2 products, a jump rope and a kickball. A jump rope yields a profit of $4.50 per unit. A kickball yields a profit of $2 per unit. The combined production level should not exceed 1,200 units per month. The demand for kickball is no more than half the demand for jump ropes. The production level of jump rope is less than or equal to 600 units plus 3 times the production level of kickballs. This is an example of a harder problem. Your feasible region for this is going to be significantly more interesting than the 2 problems I gave you for homework. your two problems I gave you homework are literally, when you graph your feasible region, they're going to be a triangle. And so you just have to plug in 3 dots here. This is going to be more. And I have a feeling this is probably where I'm going to have to pick up tomorrow. But before, as complicated as this problem is, let's see what we can do in the last couple of minutes. What are we trying to optimize? What are you trying to maximize or minimize?
You're trying to maximize the profit.
Profit, right? And so as ugly as this problem is, it's still easy to identify what you're trying to maximize. So if I'm trying to maximize profit, I say P equals. And do I know, did they tell us what profit, did they give us numbers to deal with the profit? Like, as complicated as this problem is, could you tell me what profit equals in terms of X and Y?
1.5x plus 2y.
Perfect, right? It tells us, right? It says profit, right? If I'm trying to maximize profit, I look at this, it says, oh, profit of 1.5, okay. So I can put 1.5x, profit, 2y. There's our profit, right? Now, remember I said this is the hard part. We have to identify this. Do we know what x and y equal? What do x represent? Now remember, x and y are always going to represent number of something. Based on this, what does x represent? Number of what? Number of, I know it's hard. Jump ropes, right? Okay. So jump ropes, and then y is going to represent the number of kickballs. And that's about as far as I'm going to get before the bell rings. But even as complicated as this problem is, I mean, this is pretty ugly. As ugly as this is, I still don't think it's that difficult to identify what your objective function is and what x and y equal. Because if you can get this, it makes the rest of the problem go by significantly easier. And that's where I'll end today, right? So, again, and so we're going to pick up here tomorrow. We're actually going to finish this problem. We'll probably finish the whole thing, actually talk about graphing. I'm also going to have a few more, 3 or 4 more examples of just practice translating these things. Because this is what I want you to be able to do. All right, thanks guys. Have a nice day.